Hello friends, this is Bindu Kumar here. Let's read this question. In which of the following situations does the list of numbers involved make an arithmetic progression and why? So what we should do is we should look at the different situations, identify the list of numbers and then find out if they make an arithmetic progression. So let us look at the first situation. The taxi fare after each kilometer, when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. So what it says is that the fare is rupees 15 for the first kilometer and that is fixed. From the second kilometer onwards, it is rupees 8 for each additional kilometer. So let's write this down on what we can understand from this question. So what we know is if you travel 1 kilometer, it will cost you rupees 15. If you travel 2 kilometers, it will cost you rupees 15 for the first kilometer and an additional rupees 8 for the second kilometer. If you travel 3 kilometers, it will be rupees 15 for the first kilometer, rupees 8 for the second kilometer and rupees 8 for the third kilometer. So if I were to write this down as a list of numbers, I will write 15 for the first kilometer, 15 plus 8 for the second kilometer and 15 plus 8 plus 8 for the third kilometer and so on. Now, what do we know about arithmetic progression? How do we define an arithmetic progression? So a set of numbers or a list of numbers A1, A2, A3 and so on are said to be in arithmetic progression if they are of the form A plus D, A plus 2D and so on, where D is called the common difference. D can be calculated by A of n plus 1 minus A of n. For example, D can be calculated as the difference between A3 and A2, which is A3 minus A2. And this value should also be equal to A2 minus A1. So given these many conditions, we can say that the list of numbers is an arithmetic progression. So let's check if the list of numbers that we have on the left hand side form an arithmetic progression. So here 15, 15 plus 8 and 15 plus 8 plus 8. So this can be written as 15, 23 and 31. So if you see here, these numbers are of the form A1, A2, A3. Now, I'll refer to the original equation. This can also be written as 15, 15 plus 8, 15 plus 2 into 8. So now if you look at this list of numbers, it resembles this form, which is A plus D, A plus 2D. So here we can see the list of numbers is very close to the arithmetic progression. However, we still need to validate the common difference as well. So let's do that. So here we will calculate the common difference. We'll say D can be calculated as the difference between A3 minus A2. So here we have A1, which is 15. We have A2, which is 15 plus 8, and we have A3, which is 15 plus 8 plus 8. So now I'll do the substitution. A3 is 31, which is 15 plus 8 plus 8, minus A2. A2 is 23. So I get the answer D equal to 8. Now let's do that one more time, but this time we will subtract A1 from A2, and we'll see if we still get the same common difference. So D equal to A2, A2 is 23 minus A1 is 15, and we still get the value 8. So as you can see, we got the same answer. Now, given all this, we can see the list of numbers that we have here is an arithmetic progression. So with this, we can conclude that in this situation, the list of numbers that are involved make an arithmetic progression. Remember to like, subscribe, and click on the bell button to get notifications on new videos.